Well, we have a question on chemical equilibrium. Example 3. Remember, we started with part 1 and we are now on part 7. So let's look at this JAMB question, this UTME question together on chemical equilibrium. Let's enjoy it together, right? So we have an equilibrium reaction, nitrogen gas reacting with what? Hydrogen gas to give us ammonia. And the reaction is actually exothermic. Being exothermic, we know why we say that it's exothermic, because the enthalpy change is what? Negative, meaning that the enthalpy of the reactants is greater than the enthalpy of the what? Products in this reaction. Yeah, that's what it means. So, in the equation above, the yield of ammonia can be decreased by, so how can we decrease the yield of ammonia? So the first question in your mind should be, what do we mean by decrease in the yield of ammonia, right? How can we decrease the yield of ammonia? So what do we mean by the decrease in the yield? Yield means the production, the amount of ammonia that will be produced. Remember, ammonia is on the product side. So if we want to increase production of ammonia, we will do things that will favor the what? The forward reaction. So anything that favors the forward reaction, we do what? Will increase the yield of ammonia. But anything that favors the backward reaction, we decrease the yield of ammonia. Yeah, because if the forward reaction is favored, ammonia is a product here. If the forward reaction is favored, more ammonia will be produced. But if the backward reaction is favored, less ammonia will be produced. So to answer this question, our mind must center on things that will do what? Favor the backward what? Reaction, since we are trying to decrease the yield of ammonia. Okay, so now if we look at the option, we can just remove one immediately, and that is catalyst, addition of catalyst. We remember that a catalyst will not have effect on a system that is already in equilibrium. Once a system attains equilibrium, catalyst will not have effect on that what? On that system. Catalyst can actually make a reaction to attain equilibrium position, equilibrium state faster. But once a system is already in equilibrium, introduction of a catalyst will not have any effect on that system that is in what? In equilibrium. So this can never be the answer, addition of catalyst, because catalyst has no effect on a system that is in equilibrium. So we'll start looking at everything that will make the production of ammonia to be less, as to decrease the yield. So what and what will favor the backward reaction? So let's look at it. What and what will favor the backward reaction? If we want the backward reaction to be favored, remember that's what the question is saying, decrease in the yield of ammonia, meaning the reaction will go backward, will produce less ammonia. If we are producing more ammonia, the forward reaction will be favored. So decrease in the yield of ammonia means we are trying to favor the backward reaction. So we ask ourselves, what and what will favor the backward reaction? Remember, there are 3 factors that we consider: concentration, temperature, and the what? And pressure. So now we look at temperature, right? The forward reaction here is exothermic, right? While the backward reaction is now endo, because if the forward reaction is exothermic, backward reaction will be what? Endothermic. An increase in temperature favors what? Endothermic reaction. Increase in temperature favors what? Endothermic reaction. So if we increase temperature here, the backward reaction will be what? Favored. And anything that favors the backward reaction will decrease what? Ammonia, the yield of ammonia. Because if it favors the backward reaction, it means the forward reaction will not be favored. And if the forward reaction is not favored, we will not produce more what? Ammonia. The yield of ammonia will be less. So if we want the backward reaction to be favored here, if we are considering temperature, temperature must be what? Increased. Because increase in temperature favors endothermic. And since the forward reaction is already exothermic, the backward reaction will be what? Endothermic. So when we increase temperature now, the backward reaction will be favored. Do we have increase in temperature here? Wow, that gives us the answer immediately. Now let's see why these ones are not correct. Effect of pressure. Increase in pressure favors the side with what? With less volume or less mole. So if we look at this reaction from here, adding this, we produce 2 moles of ammonia gas. Now, how many moles of nitrogen do we have here? 1, 3. Total mole here is 4. Total mole here is 2. So increase in pressure will favor the side with less mole or less volume. Less mole or less volume. Now, if you look at this, if we increase pressure, it will favor this because this side has lower volume or lower mole, right? And if you favor this, it means more ammonia will be formed. So it cannot be this. Increasing pressure will not solve the problem, will not answer this question, because we are trying to decrease the yield of what? Ammonia. So it will be things that will not favor the side of ammonia, but the reverse side. Okay, now we can see that if we increase pressure here, it will favor the side with less volume or less mole. And in this case, this is the side with less mole. That means the forward reaction will be favored. And if we favor this side, we produce more ammonia. But that's not what the question wants. The question wants what will decrease the yield of ammonia. Okay, then let's look at this. Why this is not the answer also. Removing ammonia as it is what? Formed. Now, we remember when we looked at the effect of concentration, we say one of the ways of favoring the forward reaction is to increase the concentration of the reactants. That's what we do. And we have 2 ways of increasing the concentration of the reactants. What are the ways? We said we add more reactants, or we introduce more reactants, or we remove the product as soon as the product is formed. So if we are removing ammonia as it is formed, once we form ammonia, we take it out. It will make these 2 to react to replace it. So the forward reaction will be favored, giving rise to more what? To more ammonia. All right. So in our subsequent classes, we are going to look at more examples. And after that, we'll now look at the law of mass action by Wage and Goldberg. And from there, we'll now start looking at the concept of equilibrium constant. I'm still your friend and brother, Engineer Ike Okechukwu. Bye.